Okay, so what we are looking at here now, as we're looking at function 1, is defined by the equation y equals 3/4 x plus 1. And function 2 is represented by the graph shown below. Okay, take a look. We have a graph here, we have our equation here, okay? And we have a multiple choice question comparing the rates of change and our y-intercept. So first we need to look at these and we need to say what is our slope or rate of change and what is my y-intercept. So just by looking at this first one right here, I can already see this is my rate of change or my slope for function 1, and plus 1 is my y-intercept. Here, my y-intercept, where it crosses the y-axis, is at -3, y-intercept. Okay? Now to figure out my slope, just choose any 2 points on here and figure out the rise and the run. So I'm going to choose this point I just came up with, and I'll also choose, let's choose this one right here, 0.82, okay? So from -3, go up 1, 2, 3, 4, 5, so we went up 5 units, and we went over 2, 4, 6, 8 units, okay? So my slope is 5/8, okay? So to compare these, okay, clearly this is 3/4, also known as 6/8. So this is going to have the greater slope. Okay? Comparing my y-intercepts, okay, a +1 and a -3, this one is also going to have the greater y-intercept. So now look at my answer choices. Function 1 has a greater rate of change and greater y-intercept. That one already works. So that should be my answer, just to make sure the other ones don't work. Function 2 has a greater rate of change. Clearly we saw it did not, based on what I found out. So that one does not work. Function 1 has a greater rate of change. Function 2 has a greater y-intercept. There's a negative y-intercept as opposed to a positive y-intercept. So that one does not work. And function 2 has a greater rate of change. We already said that doesn't work. So my answer choice must be function 1, greater and greater, which is choice A. Now looking at the next problem, it says, an above ground swimming pool in the shape of a cylinder has a diameter of 18 feet and a height of 4.5 feet. If the pool is filled with water to 6 inches from the top of the pool, what is the volume to the nearest cubic foot of the water in the pool? Okay. Now, I already have the formula wrote out here. You guys can find this on your reference sheets. Now, an easy way to think of this is to actually draw this out. Okay. So, I were to draw this out. There's my cylinder. Obviously not drawn to scale, but there is my diameter of 18 feet. 18 feet. And my height is 4.5 feet. But remember, I'm actually filling this 6 inches from the top. 6 inches, half a foot, so it's only going to be filled up to 4 feet, as opposed to that 4.5 feet, which should make my problem a lot easier. Okay? So now I have to take my measurements and plug them in. Volume equals pi times my radius squared. 18 is my diameter. My radius is going to be 9 squared. And of course my height of 4. Okay? Volume equals pi times 9 squared. Remember, 9 squared is not 9 times 2. It is 9 times 9, which is 81. Okay? Still times my 4. 81 times 4. Volume equals pi times, it would be 324. Now in this case, because my answer choices are so far away, I'm actually going to even estimate this as 3, because all I know is I'm looking for an answer close to one of these. So 324 times 3 is going to give me an answer. It should be around 1,000, and it is around 1,000. Obviously, this is only 3, not 3.14. So my closest answer choice in this case would be choice C. And once again, I used a big estimation there, which is why it's a little bit off, but all the other choices do not make sense in this case. So my answer is choice C.